There you go. Okay, so Johan is an actuary by training, but he's converted to a data fanatic. He was at OLX and DGL Source, and now he's consulting machine learning engineer, and his favorite dinosaur is the velociraptor.
Yes, exactly.
Don't know why that was relevant. Yeah, he'll be talking to us about anomaly detection. So, Johan, thank you very much.
Hello everyone. Thank you for the warm welcome, and thank you for the fantastic. So I'm Johan. Hello, and I'm not going to tell everyone about the normal things one year, in this pitch. We've all seen the cool models. We've all seen what machine learning can do and such. I'm going to tell a story about how to not just deploy models, right? But monitor them after they've been deployed and actually see what's happening with your code. I'm going to take an example of what every one of you go through on a daily basis, right? Of your Excel spreadsheets and everything, and how you can take that and turn it into a model by itself. To monitor your own models and be that much closer to what you call polymorphism. What that means is, suppose I design a simple regression model and my accuracy is 80% today. I do my logs and everything, tomorrow it's 85%. But what happens if something changes? What happens if it goes down to 60%? How will you know? Do we only know when the ticket comes in sprints? Do we only know when profit has gone down? What if you design one model, but actually you need 2 models or 3 models, or 1 for each season? We do everything we can, but at some stage, for true AI to be sustainable, we need it to adapt. But adaptation can only happen if it's been taught to adapt to something in particular. What I'm going to show now is a framework or methodology that one can use to not only have scalable code, but scalable models. And what I would think would be the start of building a model to build models. They say Amazon or AWS productionizes thousands of models per hour. Right. How I see it is with infrastructure as code and containerization, all these Kubernetes concepts and such, they can only happen with proper unit testing, of course. But how do you unit test a statistical calculation? So, no further ado, this is anomaly detection by Johan Olivier, that's me. I'm a machine learning engineer by trade, actuary by training, and I like to drink beer in my free time. So, anomalies, what is it? It's the black sheep. It's the black sheep or the white sheep anomalies. All we know is different. We say it's statistically significant. You all would know from a graph, that's an anomaly right there. So, there are many use cases for anomaly detection, right? You can either apply it in stocks or markets or boring actuarial science things, whatever. But yes, a real life application, right? So suppose that you design an algorithm, we design one, and this microservice gets used by most of the developer, right? But that code base runs day and night. It's such a thing that people are hiring IT teams by the hundreds, and their only jobs is to sit in these big, cold, dark rooms with TVs all around and monitor all the metrics, right? But then when something happens, I mean, it's IT, stuff will happen. We won't have jobs if everything works the first time. let's be honest, right? I mean, the mere fact that it's Apple and Microsoft or Databricks and AWS and Azure tells you there's no silver bullet, but there is, right? So things will break. It's not a matter of if, but when. Right. Fun pro tip or nerd tip, in a Poisson distribution, you get what you call a waiting time. If you drink 1 beer every Friday afternoon, right, the normal amount of days you have to wait for to drink a beer is 7 days. Similarly, if you get 1 issue every week, then you go 2 weeks without an issue, you should be worried. Same sense, when stuff does go wrong, right? And the house burns down. What do you save? Do you save your current master machine learning branch? Do you save any other blockchain stuff? No, you save event logs. Tomorrow morning, Mr. Developer is going to rock up, with his backend pants, and he's going to see what's happening on right. And it's all fun and games, ladies and gentlemen, but at some time we're going to say, it wasn't me, it wasn't me, it wasn't me. We all know that. Right? So event logs. In God we trust, all others must bring logs. I'm sorry. So, let's look at the machine learning application side, life cycle. This is a close oversimplification. What I'm trying to point out is the following concept. Suppose Mr. CEO says he wants this feature, or Mr. Product Owner promises that, right? You create the feature branch, you validate your model, right? So it works as it should work. And then you productionize it, and then it runs, and you go home. Logging info, your logger, that's basic information in your logs. But suppose something happens, an exception occurs. Right? It could either be an error, meaning a syntax error or a programmatic error, or it can be a statistical error. For example, getting a probability less than 0, or determining that the coronavirus has a death rate of 10%, but we know it's only 2%. Point is something that we test for. So in practice, what happens is logging. If it's a coding error, it goes to DevOps or Mr. Developer, that's not data scientist, gets fixed and goes back to the pipeline. If it's a model issue, a data science issue, there's a special logging mechanism. Right. Up to now, people know info, debug, warning, error. More and more in productionized systems, there's a fifth one, it's called statistical. Every time we make a simple calculation, we assume axioms, we assume certain conditions to apply. Right. But unit tests don't exist for those conditions as of yet. Up to now. So when the issue happens, we validate the issue, data science, fix it, there you go. Now all this is being done manually. We all know it takes at least a year to fully productionize a model. 3 weeks, 60% accuracy, another 3 months, 80%, well done. Productionize it, 2 weeks, cool. But then it's back and forth between the clients, tweaking the model, because that's the nature of the beast. And furthermore, the model is going to be used for years to come. So a year development, everything is, the contrast not that much. But we know if you don't analyze your model for at least, a long time, then you know that you're going to suffer accuracies. I personally spend at least 1 hour in Excel for every hour I spend in Python. Fetching graphs and all of that, because that's what you do. So, here's my use case. Application log mining. I say, or actually what's being done, you should log applications, or you mine application logs. From anyway. Earlier I heard someone mention Elasticsearch or Kibana, which is quite nice, but it's very fast, but it's not relationalizable. But if you either create a custom SQL parser, or you create something of that sort to enable a BI person or a stats-ready person to mine those logs, you can mine those logs and then pick up anomalies and change your code, or actually spit up new models as you want to. Low-hanging fruit. The guy says the tech support, I think the survey is done. Right? We all know this, right? But why must the user know first? Why do we allow the users to be the one telling us this down? We should know it before the user does it. Your normal developer operation person spends a lot of time looking at such graphs, right? But we are forcing someone that doesn't know data to know data by showing them the graph. If you take away the seasonality for them, then it's much easier. This is theme DevOps. And this, so we're here, okay, so you guys know I take a lot of service crash every year on Black Friday. right? And you guys know about lambda, right? So what if, if take a lot merely apply the central limit theorem and seasonality elements, they can predict their load and therefore not crash during Black Friday. It's good. It's that simple. Same thing. We can do it with server load as well. So theme data science, model validation. When I create a model and I say, cool, Mr. Manager, cool, Mr. Client, here's my model. My accuracy is, I'll say it's 80%, but my specificity is 90 and my sensitivity is 70, but that's okay. Right? And I do this every time I deploy. Well, it may be automated. But do I check my confusion matrix every nth call? How often do I check it? How often should I check it? Right. And these are questions which you have to ask yourself if you're going to rely on AI saving a life. I know this isn't the most glamorous part of AI, but in order to do it, what we want to do it, we need this. You get weak AI and strong AI. Weak AI is where you use it as a tool to help you do something. The strong AI is where you actually bring it that much closer to your sentient being. Look at the children asking questions. Our models also need to ask questions. Reinforcement learning. If our model behaves in an unexpected way, it's told to do so. Right? I'm a simple man. I do my job, I do these things, but certain things in life I like to outsource. Right? So if I do something wrong, tell me. Our models want to think the same way. Right? And we say this is to do with anomaly detection, because if your model has anomalous behavior, it must be reinforced with the correct behavior. Up to now, I've used very simplistic points, very well-known statistical concepts such as significance and all that, right? And I've used central limit theorem and frankly, these are all very elementary concepts. But the only thing is, we can apply them to logs. All the data out there are gathered from applications. We don't actually, well, you think about it. Think about all the data used on a daily basis. It's all the result of an application, or most of it, right? We don't necessarily, get traditional data. So we mine logs. And we can mine our own logs from our own models. Anomaly methods. We use basic time series. That's simple. Or actuarial, right? That's perfectly viable. I mean, I see nothing wrong with that. Hypothesis testing. There's a can of Coke in that fridge, right? When a factory manufactures a can of Coke or any item, they have what we call wastage. They say they will allow about 4% of them to be off. Right? I don't know, less than 5%. But the point is, any manufacturing company also works with a type 1 error, meaning, the cutoff, right? Now, why is it that a manufacturer can have a 2% error, but we expect all models to have a 0%? This building that we're standing on at the moment, right, as a fault error of less than 5%, well, I'd say, I don't know what it is, but the point is, it's not 0. So while we as arrogant to assume our model, our code, will have zero errors. Now, why do we promise that to our clients? Think about it, right? And furthermore, if you make these things, if you capture these errors and exceptions, right, then you can find when they occur. And all of a sudden, we have the ability to find which person breaks the branch or when, right? And we all know what it's like dealing with legacy code, right? I mean, we have to do it. It's the name of the game, but sometimes it's much easier knowing which script causes the error than which piece of logic. Simple stuff, ladies and gentlemen. But now we've gone to the real thing, opportunity cost. So I can't use my own clients as an example here, but okay. Suppose that you deliver a service to someone, right? And you are 24/7 business. AWS, perfect example. Suppose it's AWS, right? And for every hour AWS, or every 5 minutes AWS is not working, you can't service your clients, right? So you lose money. It's a technical outage, right? So, especially in a modern microservice architecture, right? Look at Uber, look at Mr. D, everything is as a service. And especially going serverless, we have server as a service, right? The point being, when these servers aren't working anymore, when these services aren't working anymore, you can't do your things, and you have opportunity cost. So all of a sudden, you expended this much money, but you got this much money. But you've got to pay those clients. So how much money are you actually losing? Right? And this affects bottom line. Because unfortunately, for AI to be sustainable, we have to get investors, we have to show profitability, we also have to show financial prudence. Because without productionized model that's monitored appropriately, right, and estimating and actually telling how much money we're losing if it isn't working, we can't even get to what accuracy we deem acceptable. Often people say, no, but AI can't be 100% correct. I would say it doesn't have to be. Right? But then the question, what's the correct accuracy percentage? Then you would say, if you can replace 8 humans with 80% accuracy, but the financial impact of the rest of 20% is negligible compared to what you get. And that is how you can estimate what accuracy you need and how much money you can save and how much money you can lose. Or you can hire an in-house data team, or you can outsource it. And especially when dealing with executives, this becomes a thing. So we say prevalence equals incidence times severity. So I'm an actuary, so I have to go back to my roots. Right? Incidence. Suppose that you have 5%. Suppose that you've got 5 issues out of every 100 calls. And suppose each issue costs you $1,000. What's the calculated, what's the estimated amount of money that you lose? And we can apply the exact same models that we use to do our main function. We can apply with anomaly detection. So, before I end off, I'd like to show you what I just tried to communicate and what I'm trying to tell you guys. The too long to read version, right? We automate a lot of work for our clients. If someone says, get me something that replaces a human being, we'll build them an automated process with computer vision, it's going to be awesome. But then we manually monitor our own code. When something breaks, we say, no, it's broken, we can fix it, what's wrong now? Right? We can apply the exact same knowledge to ourselves. And tools such as Kubernetes and all these platforms have helped us a great deal with productionizing our code, right? But we need to keep a finger on the pulse. Because how do you raise a baby without monitoring it and without telling it what to do? You want artificial intelligence? Much like you'd have a child. If your child exhibits different behavior, you have to notice. If a model exhibits different behavior, why? Thank you. Any questions?
I think just a comment or statement to add to what you were saying earlier. So Netflix also uses the same artificial intelligence to implement it on their production systems because they deploy about 1 million containers a week. Mm-hmm. So what they do is that that's how they're able to have such a large scalable system. That's why, for example, I've streamed on Netflix on 3G, so not 3G, LTE or whatever, but not fiber. And I've never ever been had a poor connection or anything of that sort. Yeah, so they use artificial intelligence to not just at a high level of other things, but also for their server workload to predict that and look at anomalies and all of these other things.
So Johan, are you saying that we should use AI to monitor AI?
Yes. Yes.
Okay, cool. Let's take it up.
Well, no, well, I'm saying we should use statistics.
Statistics,
But
for sure,
AI
yeah.
is built off.
Simple anomaly detection, yeah.
Exactly.
To monitor your models.
Get you far away.
And then how do you get the logs out of your models? What's your log for your models? Is it, yeah.
So that's a very good question. And without going too nerdy and technical, I actually want to very much, but this is not the time and place. Prudent application design is prudent architecture. You get what we call aspect-oriented programming. What it means is, well, in a typical data science view, it's the cool stuff building the model and all the engineering fluff that goes with it. It's not fun. But if you do the hard work and the fluff and making sure it's logging correctly and all that, then the fun will be so much better. It's like working in a dirty kitchen. If your kitchen is dirty, how can you be empirical about it? Right, and we are empirical people. So to answer the question, how do you get the logs?
You build them.
You build them.
Build it into your app, into your machine learning
Yes.
infrastructure.
Exactly so.
Yes.
So if anyone looking, you can start with logs. In Python, import logger and logging.info. You can literally replace the word print with logging.info. Right? And that's a good start. And what's nice about it, this thing has been done for us by a bunch of developers out there. And you can use it as instance. And don't be shy to use Docker. Right? Because Docker has already packaged very nice environments for people to use. So Docker file, you import or you get an image from Docker and you just add what you want. That's it. That's an answer to your question, John.
100%.
So something I struggle with just like normal application logging and monitoring is like false alarms. So
Yes.
like you just send your head up and you get to a point where you're like, it's probably nothing.
Yes.
So how do you balance the opportunity cost of sort of being done with regular work by anomalous anomalies that are impacted
I'm with you.
within the distribution? Or
I'm with you.
how do
So,
you balance those concerns?
so I'm going to answer that with a story. Okay. I once built something for a client, right? But he wanted 2-minute alert time on a metric that's very sparse and all that, and he wanted this to be done yesterday across all levels, all dimensions, right? And I made the mistake of not saying no, because why I say that, right, is because to answer your question, are you avoid false positives? Is that you do the exact same mistake and you cheat it with building a model, right? And if you're getting too many false positives, then they're not useful. But then if you identify what features are giving you false positives, you create a correlation matrix correlation matrix where you determine which confusion matrix, which vectors result in that. And then you segment it appropriately. And that will also end up telling you a lot about the features by itself. So, to answer your question, if you're getting a lot of false positives, then something which you will have to determine anyway, because it's a symptom of your main model. Given that you have accurately captured your model's features. Does that make sense?
Hi, I'm Ross. I'm from Takealot. I just want to say we didn't go down this Friday, so this Black Friday, so it's gonna be good.
You guys bought another Switch?
We went to Google. My question is around what would your approach be around unsupervised learning, where there is no definition of right or wrong, where it's a lot less sort of constrained. So for us, it would be like frequently brought together products.
Yes.
So, and you have a model that does what a frequently bought or similar products are. So what would your approach be to that when it comes to figuring out if it's performing as it should?
So my approach in this particular case assumed that there's a confusion matrix. And my approach, as such, assumed there was model validation done at some stage. So this compound approach that I'm using merely automates the validation of the confusion matrix. So to answer your question, if it doesn't have a confusion matrix, then this approach wouldn't hold. However, that's a fascinating question, and it's something which will have to be looked at in the future. I would then advise something such as the logical Prescott model. It's quite nice. Off the top of my head, I can't. Please don't quote me on that yet.
Yes, yeah.
Is there some like click-through method or something?
Well, there's a lot of stuff, but it's doing exactly what you would expect it to do, right? You define the rules, and if you're looking at something like similar products, you would define what you define. I mean, it's whatever metrics it looks at for similar products, it'll do exactly what you told it to do. But a lot of times you have to eyeball it and see if it actually makes sense.
What about generative adversarial neural network?
Yeah.
What about that? Maybe that's something.
Yeah, something we could look into. A lot of times, but then you have to have QA on that.
Right.
So.
Yeah.
So
There's always another AI.
Yeah. So I feel these things are, it's a perfect example of weak AI and strong AI. Strong AI is what people think about robots, but well, we all know weak AI is a matter of you replace the same amount of manual work by your specificity. If my model is 80% accurate, if my RPA process is 80% accurate, I'm going to say it saves 80% of manual effort. Because I'm still going to need 20% there to make sure my model wasn't insane.
Yeah.
Because I'm also
So I think this is a very simplistic question, but I think it's actually in the same vein as the previous one, which is, I quite like this idea of saying that we need to think about a new type of log level. You know, it's really a new class of error, right, that we see in our systems. Do you have like a good rule of thumb or good suggestion around, you know, how you should be flagging out statistical data in your logs versus, because arguably like certain types of facials, right, are actually statistical ones. It's such a rare case that you just didn't conceive of it when you were designing your system, right?
Yes.
So,
what I do is I build a model as is, but when I'm done, I look what's in my Excel spreadsheet. And for starters, then I just replicate that. And I make a drive to a database or whatever method that's available out there. Preferably something as robust as the time series indexes for sun jobs and sorts. Right? Anything you put in Excel, just put that there and put it in code. I think that would be a good start. But over and above that, something where you would have to look at your timelines or project timelines. You have to look whether you're following a test-driven development process or behavior-driven development process. What your sprints like, do you 1 week sprint, 2 or 3 week sprint, what can you afford? Because all we know, right, is our code breaks. I'm sorry, but it does, right? You want to spend 10 hours cleaning up or 10 days? How many weekends do you want to be on call? And how many failures would you allow yourself? Only one Tesla car has to drive into a wall for it to be feasible. However, if I could recommend that 10 bad reviews on Netflix, that's okay. I watch one episode of Gossip Girl and I'll have finished. right? So that's fine. So replicate your Excel spreadsheet. That's my rule.
Right. No other questions? Then Johan, thank you. Yeah, I think that's it, folks. We're having another meetup at the end of this month on ML tools. And people have 3 15-minute talks. I'll be giving one of them. That's it. Hope to see you there. please check out our Meetup page. Please follow us. We're also on Twitter. That's it. Thank you for coming.
Cool.